Students, look at this question. There is a carbonyl compound I can see. This is carbonyl, right? This is alpha. Even this is alpha. When I will see formaldehyde, it is clearly given it is taken in excess. I know this is containing alpha hydrogen, right? 1, 2, 3, 1H is there. But here there is no alpha hydrogen. So let me rub that off. Here you have one alpha hydrogen without any doubt. Formaldehyde, carbonyl, it is not attached to any carbon. So alpha hydrogen here is not there. Sodium hydroxide, alpha hydrogen is there. It is crossed aldol reaction. Everyone knows it. Crossed aldol reaction. I should know that aldol reaction is all about alpha hydrogen attack. Somebody who has got alpha hydrogen is attacking. Somebody who is not having alpha hydrogen is under attack. So under attack, you write it as it is. The only change you do is you make this O as OH. Okay, and exactly I know that H came from this alpha, so it attacked this. Now whatever remained, right, that will attack this carbon. This is a trick. Now after CH2OH, let me show this carbon is attacked by this. You can see it has two carbons. Let me write it as it is. Then it is attached to double bond O, C double bond O. That C double bond O attached to the ring of benzene. Clear? I can write this. Now it is clearly given that formaldehyde is present in excess. Before that, sodium hydroxide upon heating. So aldol we got, right? It should undergo condensation. Ketone, alpha, this is beta. Beta can lose OH, alpha, 1, 2, 3, 4, already satisfied. Alpha has no hydrogen, so condensation not possible. Okay, so here aldol condensation not possible. Now you take formaldehyde because it is given in excess. Without any ambiguity, I can write it. It is given in excess. It has no alpha hydrogen. Even as you said, this is also not got any hydrogen. So 0 alpha hydrogen, 0, 0, canny 0. But it is again crossed canny 0 reaction. Crossed canny 0's reaction. I know reduction and oxidation takes place. But when it was only formaldehyde, formaldehyde underwent reduction, formaldehyde underwent oxidation. When it was only benzaldehyde, it underwent reduction, it underwent oxidation. Now you have a two different carbonyl compound, right? Now the question arises, who undergo reduction and who undergo oxidation? Remember the fact, somebody who is more reactive will undergo oxidation, another one will undergo reduction. So out of aldehyde and ketone, who is more reactive? Aldehyde is more reactive, so it will undergo what? Oxidation. I know that it is undergoing oxidation, it will become HCOOH. The product you will get a formic acid here. The one more will undergo reduction. I know reduction means one H will be coming here, another H will be coming to carbon, so O become what? OH. So this is what reduction product we get. So we are dealt with the step 1. Let's look at the step 2. It is given that this alcohol is going to react with the carbonyl compound in the presence of acid. Recall you studied this in the theory. Whenever aldehyde reacts with alcohol, what you will get? Oxygen is negative, carbon is positive. Hydrogen is positive, remaining is negative. Negative go to positive and positive comes to negative. What you get? Let's write. Positive taken up, negative OR, O become OH, and of course this H I am writing as it is. Further, when you treat here alcohol, I know that this H and OH go out as water, and the final product what I am writing, that looks like this. H and OH went out as, sorry, this is not this H, I'm sorry, this H. This H and OH went out as water. What is remaining? OR. OR and H. It is geminal dialkoxy compound and we called it acetal. So the final product we get acetal. We studied this in the boards. Aldehyde, alcohol, the final product you will get looks like this. One more reaction I can write. Here carbonyl compound monohydric alcohol, right? So I can write aldehyde with a dihydric alcohol. See this. Aldehyde, dihydric alcohol like ethylene glycol, let's take 2 and 2, 2 and 2. You can see O and H2 went out as water. Now what is left out is the product that looks like this. So here one bond, here one bond. So you get the cyclic structure that looks like this. It is cyclic acetal product. You studied this in theory. Now let's see how to use that particular reaction here. Can you see the reaction of alcohol dihydric now with formaldehyde? So let's write the reaction. Let me remove this formic acid. Anyhow, there is no use of it. I'll rub all these to make space for writing further reactions. Let me do little arrangement so that I can write reaction like this. A proper cycle I'll be able to write then. You see this is attached to OH. So let me write this is attached to OH. Further, the same carbon is going up. And that carbon will be having 2 methyls, right? Then it is going up and it will be having CH2OH group. Done. Now let me show the formaldehyde. HCHO. Now let me show what is going out. See, if you know the theory point, you can apply the same concept and you will get the final product here. So let me write benzene. Everyone can see how many carbons there in the ring. You have attached to carbon. Yeah. It is like 1, 2, 3, 4, newly attached 5, 6. So I can show you the proper benzene here, like benzene ring kind structure. You can see. Oh no, I'm sorry, it cannot attach directly. You have a ring that is attached to this carbon. From here there should be hexagonal. So like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, now it's become proper. Now everyone see this at 1, 2. At 2 you have, if it is 1, it is 2. At 2 you have a 2 methyls. Then 3, yeah, here. Then 4, it should be oxygen. Then we have a 5th one, carbon. And again 6th one, we have oxygen. Done. So exactly if you look at options where you have the same structure, you can see benzene attached to this. 1, 2, there is a branch. So, okay, it has shown like this. 1, 2, there is a branch. Then we have a 3, 4 oxygen, 5, 6 oxygen. Yes, exactly this and this structure are same. So we have to tick option A as right answer.